Passing by reference or passing by value. What is the difference and why is this the cause of most debugging sessions you have in JavaScript? In JavaScript we have two kind of types. We have the primitive types that are boolean, strings, numbers, null, undefined, and also some more, but the ones I mentioned, they are the most common ones. What makes primitive types different from other types is that they are immutable by default. So the value you're assigning to them is just a value. If you add 1 to the 10, for example, to get the 11 is a completely new value and you cannot change the 10. Also, primitive types are not objects. Objects are arrays and objects in the JavaScript object notations, but the bool, the string, the number, null, undefined, and for example the symbol, all of these are not objects and they don't have methods and they don't have properties. If you want to access methods of, for example, the string, to access the includes method, this does not exist on the string. On this value it does not exist. When you try to access the methods of primitive types, the types or the values are outboxed with a wrapper object while you are trying to access these methods. So under the hood of JavaScript, the string is, when you're trying to access the method, is actually wrapped inside of the instance of the string class. So that's why they have methods and that's why you can access them. Also, primitive types are only passable by value. On the other hand of primitive types, we have objects. Objects are arrays, objects with the default JavaScript object notations, and also functions. Functions are objects, they are just callable. The interesting thing about objects is that they are the only mutable values. So we can access them and change them. We can change the actual value living in this memory location, what we can't do with the values or with the primitive types. Objects are also passed by reference, and we'll get to that later. I have some assertion console logs down here that checks if our array set to this array is equal to literally the same array. Of course the quotes are a bit different, but that doesn't matter in this case. Down here we also check if the object is equal to literally the same object. And also we check if this array copy pasted to this array is the same. Let's run it. Oops. Let's run it and we will see that all of these are false. But why? Why are they false? Why are they not equal to each other? And I'll get to that now. Let's see what happens when we're passing a variable, for example, into a function that contains a primitive type. These types, all of the primitive types, are passed by value. So what actually happens when we're passing something by value? We can see that we initialize the number 1 that is equal to 10, and we're initializing a new variable called number 2 that's equal to number 1. So now we are setting the number 2 value to itself plus 5. Let's see what comes out of it. We can see the number 1 is still equal to 10 and the number 2 is equal to 15. But why didn't it change the number 1? Because we set number 2 equal to number 1. So shouldn't the number 1 be also changed because we kind of set it to the old value, to the old number 1? And this is what we would expect, what doesn't happen. This is because it is passed by value. And in memory, in a really simplified manner, it's just copied. So when we are setting number 2 to the value of number 1, this is what happens. The number 2 is equal to the value that number 1 was at this moment. And it's not pointing to the same location, it's just the same value, just copied. On the other hand, if we're passing by reference, something else happens. So we're initializing an array A variable containing the array containing 1, 2, 3. We can lock this array and we are initializing another array, array B, that is set to the value or to the reference, because we're passing by reference, of array 1 or of array A. And then we are pushing 10 into the array at the end to array B, and we are logging array A, and we can log array B as well to see what array B is. So let's see. The first log shows us that array A contains 1, 2, 3. The second log shows us this array A also contains the 10 pushed at the end, but we just pushed it to array B, didn't we? That is not what we were expecting, but it is what's happening. And we can see in my little graph down here that what happened is we have array A, we have array B. And these are, for example, both set to the value of the actual memory location. And this is just an arbitrary address I made up here. while evaluating this JavaScript code, this array is evaluated, saved into memory, and then the reference is passed into the array A variable. Then, when we set the array B variable to the content of array A, it's not set to the actual array, it's set to the reference of array A. So then both of these variables are pointing to the same address, which you can see here. And this address is pointing to the value of the original array 1, 2, 3. And then when we push or when we modify the array B, because objects are the only mutable values in JavaScript, we are actually mutating the value living at the address location of array A that is now set to the same value of array B, or it's the same value living in array A and array B now because they're equalized here, and or they're assigned here. And now we are modifying, we are mutating the value or the reference that the array B value is pointing at. So we are mutating this 1 to 3 array, pushing a 10 at the end of it, and then we're checking what happened to array A, what happened to array B, and both of them are pointing to the same memory address, so both of them are pointing to the same now modified array, just console logging the same array. And we could also check if these are equal. And this is just array B equals to array A. And we can see it's true because it's literally the same memory location. It's the same object. Here's also another example with a literal JSON object and not an array. And you will see it's doing pretty much the same. So we have object A. Let me just save it. We have object A that's set to the object containing a property called A with the value of 1. We're locking the object. We're initializing an object B that is set to the reference of object A. We are adjusting object B, creating a new property inside of it called B and setting it to the value of the primitive number 10. And then we are logging object A. And we can also, like before, log object B and see if they're actually equal. Object B equals object A. Let's run it. And we can see object A at first is logged with just the A and the 1, or A set to the 1. And then we're doing our little calculation here, setting object B to the reference of object A, modifying or mutating object B, adjusting or adding this B property inside of it. And then we see object A is mutated, object B is also mutated, and they are equal. Because like here, this should be object A, and the other one should be object B. These are both set to the same memory location, so adjusting this memory location will affect all of the variables pointing to this memory location. Alright, thank you for listening. If you stayed until the end, then you're the best, and I hope you don't do any of those silly passing by reference mistakes anymore.